Zonex has developed a new concept in air delivery for VRF systems. Now you can effectively and easily add zoning to VRF systems with multi-position air handlers and ducted mini-splits with Zonex's VRF-VAV offering. Again, you can use a single multi-position fan coil to serve multiple zones. The VRF-VAV system utilizes smart air valves, or SAVs, which are pressure-independent and self-balancing dampers that deliver a targeted amount of CFM to each zone regardless of system static. Each SAV has the ability to monitor the air volume through it and make adjustments to its airflow on a continual basis. The SAVs allow us to effectively zone inverter-driven systems, reducing amp draw and kilowatts of power, providing proven energy savings by controlling airflow through the air handler. Today, we'd like to review the operation of the VRF-VAV, its components, operation, and proven energy savings. Here we have a 3-ton Mitsubishi VRF system, a multi-position vertical air handler with a manufacturer's thermostat interface to communicate with the VRF system, zone controller, 3 zone stats, and 3 SAVs or smart air valves. Our front-end zone controller wires to the VRF system through the manufacturer's 24-volt thermostat interface to initiate calls for heating or cooling. The controller polls each zone thermostat every minute to determine system operation. Thermostats communicate with the controller located on each smart air valve that is equipped with a pressure sensor. In this demonstration, we have 3 10-inch smart air valves that each have a targeted velocity of 460 CFM plus or minus 10%. The smart air valve is not just a damper, it's the key to our system. Let's run this simple system through its paces. Smart air valve number 1 is connected to an air hood, so we can report and see the CFM flowing through that SAV. The other 2 SAVs are set for the same targets. With all 3 SAVs flowing around 460 CFM, again plus or minus 10%, at 0.20 static pressure. There is a total 1,380 CFM flowing through the fan coil. As you can see, the outdoor unit is currently drawing 17 amps with 3 zones calling. Now let's see what happens when we turn one SAV off. Let's satisfy the call on zone number 3 and take a look at the damper controller board on the SAV. Note the red light is on and the SAV is driving to the closed position as air delivery is reduced in that zone. Zone number 1 CFM remains close to 460 CFM and static pressure has risen to 0.4 inches. As we see here, even though our system's static pressure has increased, the SAVs, or the smart air valves, continue to deliver their targeted airflow regardless of static pressure changes in the system. This is impressive, and this is the key to VRF-VAV. Other systems using standard dampers provide erratic and unmeasurable air delivery, resulting in on-off operation and no energy savings. This is not the case with Zonex. No bypass is required, and the smart air valves, again, are pressure independent, self-balancing. As you can see, with just 2 zones calling, the outdoor unit is now drawing just under 13 amps. We are now around 75% of amp draw compared to when 3 zones were calling. Let's close zone 2 and see what happens now. Zone number 1 CFM remains close to 460 CFM, its targeted velocity, and static pressure has risen to around 0.5 inches of static. Once again, our system static increases, but zone 1 continues to deliver its targeted CFM. Looking at the board on the SAV, you see it's still hunting for that sweet spot and will deliver targeted air velocity within plus or minus 10%. Red indicates a damper moving closed, green moving open, hunting to find that targeted velocity. As you can see, with just 1 zone calling, the outdoor unit is currently drawing just under 7 amps. We are now at about 50% of power consumption compared to when 2 zones were calling. This system is designed to reduce compressor power and power consumption just like a cassette, based on changes in airflow and the SAV's control of the fan volume. Here is a table and an associated graph that compares CFM and energy savings, all based on the data shown in the video. As you can see, reducing CFM flow through the fan coil saves significant sums of power. A system designed for 95-degree days can operate at less power, saving money every day that it isn't 95 degrees outside. And if this is a heat pump system, you'll save money all year round. VRF systems, as you know, are exceedingly efficient and provide exceptional SER. As we are seeing, many cities across the U.S. are not allowing fossil fuels or the installation of oil and gas furnaces, making this the perfect time to offer a multi-position, energy-saving VRF air handler, providing individual room-by-room comfort and temperature control. And you can even reuse the existing ductwork if it's there. And if your customer doesn't want thermostats on the wall, we have the solution for that as well. Use our temperature access points. We call them taps, to wirelessly communicate with the smart air valves in your system. The Zonex solution provides superb operation and energy savings. It cuts your cost, it simplifies your installation, and you retain all the benefits and energy savings of VRF, and will help you land the job.